Hello, my name is Eric Reinerson. I'm the Director of Analytics at InsideTrack, and I'm looking forward to speaking with you today about visual monitoring with Tableau as an aid to predictive model deployment, which is really a specific use case at InsideTrack among the many that we have for Tableau. We also use it for things like, as a replacement for PowerPoint in generating a pretty presentation. We also use it as a complement to SSRS for our standard reporting. And of course, it's something just as a desktop analytical tool. But what I'm going to talk about today is how we've used it as a way to ensure that our predictive models are being scored correctly, which might sound like a mundane topic, but actually is extremely important and was, I thought, made pretty fun by my experience of doing this with Tableau. And so that's why I wanted to share that. Hopefully, I'll inspire some people to shine a little bit more light on their automated complex data processes, whether they're related to predictive models or not. So, in particular, I'm focusing this talk on people for whom any of these apply. Number one, if you're relatively new to Tableau, I'll have some practical tips towards the end here. I mean, even down at the level of some kind of dashboarding tips that helped me that I actually wrote as a beginner, so they'll be won't require any sort of Jedi training. It's pretty basic stuff, but handy. And also, if you're new to Tableau and you're thinking about what can it do besides make nice graphs or give you a chance to sort of play around and explore data, we found it to be very valuable for an automated sort of data process checking approach. And also, if you use Tableau for predictive modeling, you've probably figured out very quickly that it's an excellent tool for exploratory data analysis, so much so that I've actually stopped using other tools for most of the exploratory data analysis that I do, because I find that I can get what I want really quickly with Tableau, whereas some of the tools like within either SAS or SPSS or R even, there's some fantastic graphical tools, but it's just really fast to do it in Tableau, which I appreciate, and speed of the speed from idea to visualization is really important when you're just trying to quickly get your head around some data. And then obviously there's the goal of looking at the return on investment from a model, which is something that everybody's got to do at some point. And if you don't think you want to do it, somebody will make you do it. And if you don't do it, some business analyst is going to be assigned to it. So those are kind of the obvious use cases. So I'm going to talk about the use case of really monitoring the process itself, which I don't know that people focus much on. And then lastly, I think any complex data process could benefit from a treatment, kind of like what I did. So I'll really focus on an example of what we did at InsideTrack, but I hope you can generalize to whatever complex data process you rely on. And then lastly, even if none of the above apply, I hope you find it interesting. And if you don't, there'll be some time for Q&A in the live session, and you can ask me questions about things you are interested in. I'd be happy to hear what those are. So I'll talk a little bit about InsideTrack before getting into the business problem and our predictive modeling approach, which we call the iScore. So this is not something that everybody knows I've encountered. When people ask me about InsideTrack, I can't talk about InsideTrack without talking about the problem that we solve, which is that nearly half people who go to school as what you might think of as a college freshman. So when you picture a college freshman, you're probably picturing somebody who's a first-time student, full-time, looking for a bachelor's degree at a four-year institution. And so those are the people you kind of assume they're going to go to college, they're going to do their homework, probably party a little bit, but then eventually they're going to graduate and they'll be fine. And a lot of people, at least that I talk to, are shocked to find that almost half of those people aren't going to graduate, at least 6 years later, which is a long time. Did they graduate after 10 years? I don't know. That's usually not something people are still tracking. But this is a disaster. College is extremely expensive. It's a lot of investment in time from the people who are going there. There's a lot of investment from whoever's paying for it, whether it's the government or the student or the student's parents. And there's a lot of investment from the school in bringing in students, tracking them to the school, and trying to get them through their early classes. And so it's really a huge problem that they're not graduating. And you might think, okay, well, that number sounds sort of crazy. Maybe that's just being dragged down by all the schools with huge problems. My school had an 89% graduation rate, so I don't know, maybe that's not representative. But I want to point out that even if you break it down by sector and you're looking at four-year private nonprofit schools, so these are some of the better funded schools, often more likely to be selective, and ultimately that's reflected in the graduation rate, you're still looking at almost a third of people who don't finish in 6 years. And that's including the 10% of people who actually transferred and finished somewhere else. So it's not like everybody just graduated from some other school. Again, this is a huge problem. And it's why InsideTrack was founded. So InsideTrack has spent the last 10 years trying to solve this problem using a one-on-one coaching service, which we'll talk a little bit more about in a minute. But we work with both prospective students and enrolled students. And with prospective students, we've seen a 10 to 15 percentage point improvement in yield, which is students who apply to the school actually going there. And then we've also seen a 15% reduction in attrition. So that means more people in school, more people graduating, and ultimately that's what we're here to do. We're coaching more than 20,000 prospective and enrolled students per month. And coaching works. I'll talk about the impact in a minute, but I just want to point out that we've worked with all kinds of students at all kinds of schools. We work with freshmen. We've worked with people starting off in graduate programs. We work with community colleges. We've worked with 4-year programs, 2-year programs, public, private, for-profit, nonprofit. Everyone from, you can see this is a partial list here, Arizona State to DeVry to Drexel, Golden Gate, the University of Hawaii community college system. So we've learned a lot about students, a lot about what makes students tick. We've learned a lot about how to make coaching more effective. And what I'm going to focus on today is a predictive model that specifically focuses on what kind of students can be most impacted by coaching. I'll come back to that in a minute. I want to talk a little bit about coaching because people hear coaching and it doesn't necessarily make any sense because most people experience with coaching is some kind of athletic coach. And I think, sorry about that. I think that's a decent analogy, but probably a better metaphor would be the kind of coaching that an executive coach or a life coach does. If anybody ever here has ever had an executive coach or knows what that's like, it's somebody who works with you and focuses on what's going to make you successful in your career or helping you get what you want from your job or from maybe a career move or something. And so InsideTrack coaching is kind of like executive coaching, except instead of being focused on your success and your job or your career, or whereas life coaching would be focused on your success doing, I'm not sure what, I've never actually had a life coach to be honest, but it's specifically focused on what makes you successful in your first year of school. So it's about helping students connect what they're doing every day to their long-term goals, help them figure out why they're in college, because a lot of people go to college without really knowing why. You'd be surprised how many people, usually college graduates I talk to, that as soon as I tell them about this, they're like, oh my God, I could have used a coach. And these are the people who actually graduated. So I think all of us, including me, I can definitely think of how I would have got more out of my freshman year and hopefully got more sleep if I was a little more organized. Could really benefit from this kind of help. And actually, if I could continue on my soapbox for a minute here, our CEO likes to make the point that all your life growing up, you've got parents and teachers kind of helping you do what you do and overseeing you in some way, and then your whole career, you have some kind of manager making sure that you're kind of connected with the big picture of the organization, and that you're kind of on the right track and helping you get your problem solved. And there's this weird period for about 4 years where nobody helps you except for some busy on-campus resources, and we just kind of expect these 18-year-olds to fend for themselves, and then if it doesn't work out, we just figure maybe they weren't smart enough or something. It's kind of crazy. And so we're really filling a gap in personalized support that people are no longer, if they're traditional undergraduates, they're no longer getting from their parents. And if they're non-traditional schools, they're probably not getting from anybody, at least in school, because a lot of the students we coach are 30-something years old. They've got a job, they've got kids, and frankly, it's amazing that any of them graduate because it's really hard to actually work school in alongside your other commitments. I'm sure some people here have directly experienced that, and I applaud any progress you've made in your continuing education because that's really hard. And so InsideTrack provides a one-on-one service that really focuses on filling that gap and helping students be successful by working directly with them. And the great news is it works. We've been keeping track of our effectiveness. One of the things that really makes us stand out against other retention solutions is that we measure our results. We've done more than 100 controlled studies. And when I say controlled study, I really mean not just comparing this year to last year. I really mean we take a bunch of students, split them into group A and group B, and flip a coin. And if they're actually the equal size, you can just flip a coin. Sometimes you have to do something a little differently. But we're randomly assigning students to either coached or control groups. And then the only difference between the coached and control group at that point, and we monitor very closely to make sure all the factors predictive of retention are balanced. The only difference between the coach and control group is the coach group got coaching. And so we're able to actually measure our results. And like I said, we've done hundreds of controlled studies, and we've actually had, there's a Stanford professor who is really focused on student interventions. Intervention is kind of a strong word. We don't really use it at InsideTrack, but technically what he considers student interventions, which is anything involving trying to get people to stay in school at a student level. And he found it really stood up to his economic analysis that not only did it work, the retention rates were higher, even controlling for all the demographic factors. He also did a further study, or maybe it was somebody else at the National Bureau of Economic Research, did a further study looking at the cost effectiveness of various retention programs, because ours being a one-on-one service, it's a little more expensive than, actually it's quite a bit more expensive than some of the really cheapo approaches to retention management. The problem with the cheap approaches to retention management is that it's really hard to improve retention, like really hard. And so a lot of them cost less money, but they just don't work, or if they work, it's impossible to see that because the impact is so small. And so when you really step back and look at the sort of bang for your buck you're getting from investing in student success, InsideTrack is one of the highest ROIs you can get. We've gotten similar recognition from government agencies. I'm running a little behind, so I'm going to cut ahead here. So while we've gotten a lot of recognition, I want to highlight one of the things I'm most proud of came this past year, actually, in 2013, when we were recognized as one of the top 10 most innovative education companies in the world, which I was particularly excited about because I'm a huge fan of Coursera, Udacity, and edX, which you can see at 1, 2, and 3. So I've actually taken a lot of classes on Coursera, so I know a little bit about how hard it is to complete online classes while you have a job and a life. And so I'm just really proud to be in the same list as leaders like that, and I think we deserve to be there because what we're doing actually works and we're solving a hugely important problem. So that's exciting. So aren't we all living happily ever after with all our recognition and praise? Actually, we are a business. We're a for-profit institution. We get paid by our clients, which are the colleges, actually. We get paid by the colleges to provide this coaching service because although they love their students and would love to provide this service to them if they could do it for free, the reason they pay us money to do this is because it has an impact on retention. And higher retention means higher rankings in the U.S. News and World Report. I don't know if you guys know this, but something like a quarter of your U.S. News and World Report's ranking is based on persistence and graduation rates. So it's a big deal for even schools that are just more interested in prestige than tuition revenue. But then for the rest of the schools in the universe, and most of them are very concerned about tuition revenue because they don't have huge endowments, keeping a few extra students in school means a lot of tuition revenue. And so the ROI is, 100% or 200% when we're delivering a 5 to 7 percentage point impact. And so that's why they hire us. That's why they keep us around. As much as they love the sort of positive effects of the service, we've got to generate a return on investment. And just like everybody else, our clients want to know, can we do more with less? And so that's the pressure we're under, and we're increasingly under this pressure because colleges are increasingly under pressure. People are asking really awkward questions like, is higher education a bubble? Can we justify what tuition it costs these days? Can we justify the fact that it's increasing at a higher rate than even medical expenses? And the answer is probably no. I mean, it's my personal, I don't know if this is the InsideTrack perspective. My own perspective is college is too expensive. I expect that to change in the next couple decades, or at least I hope it does before I send my own kids to college. And so basically, InsideTrack, just like our clients, need to find out how to do more with less. And so that's what we're focused on. We're answering this question. I spend a lot of my time thinking about this question of, can we coach less than all the students and have the same impact? And that question really comes down to, who are the students who are most impactable by coaching? Because coaching is supposed to increase retention. Can we find the people whose retention will be increased if we coach them? So that brings me to the I-score. So the I-score is a predictive model. And like most predictive models, it gets fed with data, and then you run some kind of learning algorithm or predictive modeling process, and then you get this model that predicts something. That's pretty standard. What's unique and quite challenging, actually, about the I-score is that since we're not focused on this question of which students are going to retain, which frankly is pretty easy to model, and there's a billion academic papers telling you exactly how to make a predictive model of retention, And there's a billion companies out there who have some kind of alert system that will give you a blinking red light if somebody might not retain. Often that blinking red light blinks a little too late to do anything about it, but that's another story. So we're actually trying to model something differently, which is we're focusing on, let me focus on this controlled study here. So we've got coached students and we've got controlled students, and we're actually modeling the difference between the coached and the controlled students. And what we're looking for are, who are the people who, if they didn't get coaching, would have been a lot less likely to retain. And so that is the second order effect it's challenging to model, and it takes a while to really have enough data to do that, and it takes a while to have enough data to know if your model worked. And so that brings me to telling you a little bit more about the model, and then I'm going to tell you how we know whether it worked or not. So there's different ways to do what we call it's sort of called, I've heard it called uplift modeling, I've heard it called netlift modeling, and there's different approaches. Some of them involve something called net weight of evidence. One of the tools that we use is a decision tree segmentation. And so if you don't know anything about decision tree models, what they look like is something like this. You've got a typical decision tree model would look something like, okay, let's say this is all students and they're maybe 80% likely to retain. If I can identify some factor or set of factors that differentiates between group A and group B within there, or within that overall group, where maybe this group is 60% likely to retain and this group is 90% likely to retain, well, now I've learned something. And so if I can go through iteratively and break down into smaller and smaller groups, at the end of the day, I've got these groups, and I can take the average retention and say that's the predicted model score for those groups, because now I've got this sort of logic flow I can put students through to score the new records. And so now I say, okay, I've learned something about who's going to retain. I'm going to apply this going forward, and this predictive model of retention will tell me what to do. And so that's pretty standard. A lot of people do that. What InsideTrack does that not a lot of people do, and if you are doing something like this, let me know, because there's not a lot of people doing this, and I'd like to talk to any of them who are. But we're actually focusing on this, again, this difference. And so here in this example, I've got an average impact of 5 percentage points. And so I've got some placement exam scores, some properties of the student zip code, and I'm breaking it down to the point where I'm finding groups of people where we had potentially even a negative 4.5 percentage point impact, versus groups where we're having an 11 percentage point impact. And this is all too simplistic, really, because as anyone who's used decision trees knows, they tend to overfit the data, and so you get something that fits the data really well but doesn't always predict well, which is why we actually use a combination of a whole bunch of different trees and something that looks a little bit like random forest, if you're familiar with that. I'll talk more about the details in a minute, but it works. So this is this is an example of what we see when we segment the students this way. If we're having a 5 to 7 percentage point impact, that could translate actually into a positive impact on as little as 30% of the students. We're able to find that predictably there's people who there could be 2/3 of the students where overall we're not impacting them at all, possibly even impacting them negatively. I'm not exactly sure what that means. We're doing some qualitative research now to figure out if that's just the model overfitting a little bit, if we really do impact people negatively. One theory I have, just to color that in, is I think part of coaching is about getting students to be realistic about what it's going to take to be successful in school, from everything from how much time they're going to have to set aside, and thinking especially here about a non-traditional student, if helping them be realistic about how much time this is going to take, where are they going to find that time, how are they going to find the money to make their student loan payments, things like that. That's really good for most students, but some people maybe just freaks them out, and they drop when maybe they would have stuck around a little longer, or maybe even found a way to do it. Maybe that realism is just too much. So I suspect we probably have a negative impact on some people, but overall our impact is good. But the important thing is here is we've made a lot of progress in figuring out which are the people we really should be coaching. And then so the question of how do you know this is working long term is you implement the model and you keep track of these, in this case, quintiles. So basically you keep track of the results of these segments. But like I said, it takes a long time for that data to add up. And so in the meantime, you've got to just make sure that nothing's going wrong. And so that's what I'm going to talk about today. This is a sort of simplified version of the predictive modeling process. Get the data, explore the data. Obviously, Tableau is a great thing to use at that point. Do the modeling. Don't think Tableau helps you with that. Deploy the model, and I'm going to focus today on how to use the model or how to use Tableau to validate the scoring itself, because at InsideTrack, since we've got this second order effect, it's kind of hard to measure and it takes a while to know if things are, if that's the best possible model or if we should switch it out with a different model. We just cannot afford for anything to go wrong with the scoring process, because this makes sure the model really is delivering value. Again, it might be several months before we could do this with any sort of certainty, and that's just unacceptable. It would be unacceptable if something went wrong here. Another problem that's particularly poignant with InsideTrack is that because we work with schools and we work with the school's data, colleges have all kinds of data problems, and even the ones with the best data have data problems, and a lot of them have very bad data, I'm here to sadly report, because a lot of them are, they're traditional institutions. A lot of them aren't very, very big on their own. They're serving several hundred new, they get several hundred new customers a year or several thousand new customers a year. So they're, they're not investing, it's not like getting data from a bank or something where they've built, really sophisticated IT systems in the 70s or something. So we've got all these different clients, most of whom are not hugely technologically sophisticated, and there's a lot of processes changing both at the client and then at InsideTrack, and so there's still a lot of ways that things can go wrong. And so I'm going to talk about how we just keep an eye on those, and I think instead of just catching the biggest problems, which you could do with a little bit of forethought, I believe we're able to catch medium-sized problems. I can't promise we catch every problem, but we, I think, do a better job than the sort of alerts that people usually build into their code when automating something, because it's hard to think of everything, and I'll come back to that idea. The one question might be, Eric, isn't there some best practice out there? Doesn't somebody do this really well? Did you really do anything that's unusual? And I wondered that, because here I'm about to present this to a bunch of people. And so I Googled monitoring deployed predictive models, and was maybe 10% excited and 90% horrified to find that actually this talk is the number 4 hit, which I think tells us a little more about just where people really focus their energy and efforts in predictive modeling, which is more on the modeling side, more on gathering data to do the modeling than it is on just the fairly mundane process of making sure that your scoring goes right and keeping up on that every week or year or minute, depending on the model you've got. But then I said, okay, well, maybe deployed is a weird word. What if I just Google monitoring predictive models, period? There must be tons of things written about monitoring predictive models. And maybe there are, but this talk, again, was the number 9 hit, even including all the scholarly papers. So I think there's some work to do here. And so if you learn anything from the rest of this talk, I would encourage you to try this at home, do what I did, do something like what I did, and just try to make some progress on this problem, which is making sure the predictive models are working. Because the world isn't, if you paid any attention to all these articles about big data and predictive analytics and whatnot, you've got the sense that algorithms and models are increasingly running the world, which is true. And I think long-term that's going to be a good thing, is my personal opinion, because I like predictive models and analytics and data. But in the meantime, it's going to get a little clunky because I don't think there's enough attention being paid to making sure they're working properly day to day and minute to minute. Yeah, I think that's what I wanted to say about that. So predictive modeling. Here's why this is getting to be a bigger and bigger problem. I'm going to use an extreme example, and then I'll bring it back to InsideTrack. So at the risk of taking the most extreme example, I think this is an interesting example, which is in 2006, Netflix offered $1 million to anybody who could improve on their Cinematch system by 10%. And what Cinematch did was it told you, it gave you recommendations that were based on things that you like. And so when you watch something on Netflix, you probably notice they say, hey, here's another movie you should check out. And they don't just say, on average, people give it a 3.5. They go, actually, on average, you are likely to give it a 4 stars or 4.5 stars, which is probably different from the average. And that's based on their assessment of what you will like, which is based on their assessment of what people who like what you like. And presumably that also factors in whether you like what other people who like what you liked or not. And it probably gets even more self-referential than that, because they use something called collaborative filtering, which is a way of designing recommendation systems. And so after a year, no one had actually got to 10%. So a bunch of teams of computer scientists and statisticians jumped on this both for partly for the money and probably mostly for the sport and or recognition and whatever else motivated them, or just because it's fun. And the leading entry after a year with an 8.43% improvement was a combination of 107 different algorithms. And I don't mean 107 different really similar algorithms based on what I'm going to talk about next, which is just resampling the same data and doing some kind of what's called bootstrap aggregation. They're using very different algorithms in different ways, including things like singular value decomposition, restricted Boltzmann machines, which is a form of neural networks, k-nearest neighborhood methods, which is kind of a pretty simple approach of looking around in your so-called neighborhood of the data that you're in and figuring out for that particular data point what it should be classified as, and more. And like I said, these are really different. And so if one of these was able to be, if one of these could be understood by somebody really just pouring through the code or the coefficients in a linear model or something, that's one thing. I mean, some of the elements here, like Boltzmann machines, neural networks are considered a black box algorithm, and that they're just hard to audit. It's hard to watch them working. You don't just get coefficients like in a linear regression. Add them all together and you've got a big black box. And if you think that's maybe a freak result, the winning entry a few years later was actually a combination of hundreds of predictive models. And this is not a fluke. This is probably a little bit overkill considering the importance of this problem and the money and recognition on the table. But ensemble modeling is getting really common, and a lot of the more standard methods for just using one approach to predictive modeling involve some kind of ensemble element. So one example is random forests, which are a way of using decision trees, but using a bunch of different resampled subsets of the data, but then also using different subsets of the variables, et cetera. And so you kind of end up with this average of a whole bunch of models. A typical random forest model, actually the default setting in most of the systems I'm aware of, is to have 500 different trees in one model. And so even something like decision trees, and this is a good segue into our own modeling. Even something like decision trees, you've got just really complex ingredients there, because it's just this tangle of different trees that are based on different subsets of the data, and you get this average that it's just really hard to trace one record all the way through. So that brings me back to the iScore. The iScore uses something it's sort of like random forest but different, and like I said, it's about impact rather than response. But a typical InsideTrack iScore model could have 15 or more decision trees in it, and so this isn't anywhere near the Netflix complexity, but still, we're averaging a bunch of models together, and so the scoring logic might look something like this. This is actually one particular model. It's not one of the ones we implemented, but it's very similar to one. And so if you get to the point where I got, which is, we've got this process where we get data from the school, and at some point I'm processing it myself using the same tool that I built to actually generate the model. I did that for like 6 months before finally pushing hard enough to get somebody to agree to automate this. And the reason I didn't automate it myself was because it's actually part of this process that is managed in another department, and I didn't want to get into too much. I didn't want to get into their business too much, but at the same time, I wanted to automate the process, make it possible for them to run it. But then, since I knew that it would be hard to audit this model, I wanted to provide them some way of knowing whether the model worked, and that's what I'm about to talk about. So the process, once we automated it, looks like this. School gives us data, they drop it on an FTP site, and then we have an SSIS job that picks up the data and scores the student. So now we've got iScores following the logic that I described here. And this is the point where Tableau fits in. I didn't want to hand this to the data analyst and just say, good luck, because it's really hard to know whether the scoring worked. You get these numbers out, and are they the right numbers? There's really no way to know that without really digging into the data. And that was kind of what I was doing early on, and then I got to the point where I sort of knew what the likely problems were, and I focused on those. But before handing this process off, I wanted to make sure that there was a way for the person I'm handing it to know really quickly if these scores look right, which is a hard thing to define when you're looking at something that you won't know if it's right until the future, but you need to distribute the students to coaches now. And so what we have is a quick process of looking at the data, and then after that we complete what we call roster management process, because we call the student list, we call them rosters. And so we distribute the rosters to coaching, and the coaching begins. And so there's this question of what could go wrong? And the answer is a billion things. I mentioned some of them earlier. Some of them have to do with fields from the school disappearing. Some of them have to do with field names changing. Some of them have to do with the distribution of the data changing. Maybe there's a program that we think we have a bigger impact on, and they cancel that program. That stuff happens all the time. And so I want to share some inspiration from the keynote speaker for this Tableau conference, Nate Silver, which is that a visual inspection of a graphic showing the interaction between two variables is often a quicker and more reliable way to detect outliers in your data than a statistical test. Also, one of those areas where computers lag behind the human brain. So he's saying a couple of things here. One, and I completely agree with this, it's really hard to define what sort of deviance you're looking for. It's really hard to know in advance, am I worried or do I think something's wrong here if, the data has, if the standard deviation is too high, or what if all the numbers are equal to each other, or there's all kinds of things that can go wrong that you can anticipate. But what a lot of those alerts that you build into your scoring code look like are really just things that you brainstormed in front of a whiteboard, with somebody else. And I'm here to tell you, you're not going to think of everything. And if you just look at the data, you're going to catch things that you would have never even thought of a good test for. And then what he's saying in the second part here is that I think he's kind of ruling out just sort of trusting computers to. I'm sure there's some clever way to use machine learning on your scoring process, possibly. And actually, he's not talking about implementing predictive models. So what he's talking about is just the analysis in the first place. And so his point here, and I've heard this in other forms as well, which is you need to point the modeling process, any kind of complex algorithms or predictive models, you need to point those on the hard part. And so most of predictive modeling, or even what people call data science, some data scientists once referred to himself as a data janitor, because most of predictive modeling or any kind of fancy complex statistical analysis, you spend 90% of your time just sorting through the data, finding weirdness, trying to figure out why it's weird, filtering things out. And so again, just the answer is to just look at the data. You're never going to think of all the tests you can run on data, whether it's to make the model or even to score the model. And then Leo Tolstoy has this great quote at the beginning of Anna Karenina, which is, "Happy families are all alike. Every unhappy family is unhappy in its own way." And not only is that a brilliant quote, but I think it applies really well to data. And the point I have here is that normal data looks normal. If you've got some kind of bell curves are nice. If you've got some kind of uniform distribution, that's great. If things fit some clean pattern, that's pleasing. But it's just not. When you're trying to look for problems, you don't necessarily know what the problems are going to look like, because every problem is unique. So here's a couple things I've observed very recently, just in the past few months. So one would be, if I was looking at, if I wanted to look at something like standard deviations here, I'm not going to catch, why are there just a whole bunch of records that all have the same score? That's just bizarre. And they're, amidst a more typical distribution, I'm sure, now that I've seen this, I can definitely think of ways I can define this sort of weirdness, but I wouldn't have known that in advance. And so part of what I'm encouraging people to do with this talk is look at your data rather than spending all your time trying to think of all the things that could go wrong. Just spend that time thinking of an efficient way to look at the data frequently. And then similarly here, this is actually two things that should be strongly correlated, but instead of all the data fitting into these buckets, you get these outliers, and it's easy to find outliers. You can always define what an outlier means. But then why are there two kind of cutoff points here? What's going on at this threshold? Again, you have to look at that sort of stuff if you're doing any sort of data modeling or sort of scoring process, because that's the stuff that's going to ruin your model, and you have to find out what's going on. So that brings me to Tableau. I'm going to spend some time just giving you examples of the specific dashboards that we used, and then I'm going to try to generalize to what you can do at home. So when I was just getting ready to implement one of these models, one of the things we noticed, for example, was there was a placement exam. There was a placement exam that the score, there was a couple scores in it that the model relied on. And up until then, we'd been getting those exams, the average values had been constant. All the things that I checked for, it was sort of meeting those standards. But then right before implementing the model, we found this. So this makes it look like we could have seen this coming a long time ago, but actually this English test wasn't even in the data, actually, nor was, I think it was the math test that was missing. And so what it looked like was you're getting these tests that are going to phase out over time. You can kind of see, for example, the red one is the sentence exam. The sentence exam is getting phased out in favor of this English exam. And similarly, the algebra exam is getting kind of phased out in favor of this math exam. And so that was actually my first hint that I'm going to need to implement this, because we're scoring students sometimes twice a week. This is a particular school where we're getting new students, 3 times every 2 weeks, because of the way that they structure their terms, or lack thereof, actually. And so this is actually the first dashboard I made. So I want to look at a few things here. One is I'm keeping track just what's the overall distribution. So obviously key insight that became clear at this point is that they're phasing out these exams completely. But what it turned out, and you might think, gosh, why didn't they tell you? Well, I am several people in between this decision and me. I mean, you've got somebody at the client decided this. Maybe somebody told the analyst who's giving us data. Maybe they told the data analyst who has a direct relationship and data flow with them, who then passed this data on to me to get ready to implement this model. That's a lot of people to keep in the loop about things. And if you've all, had challenges in the organization, like I think every organization does, of just balancing too many emails versus keeping people in the loop about things, nobody 8 steps away from me is thinking about, gosh, I wonder what's going on with Eric's predictive models. I hope he has all the information he needs. That's just not what everybody wakes up thinking. And so it's on me to look for these kind of problems. And so nobody told me they were phasing out this exam, which is normal. They actually, what they did was they delayed it until after the start. And so that actually was really important because of the timing of the models. Anyway, so now I know that. Luckily, I caught that in time. Ended up having to redo the models from scratch. So another way to look at that is in terms of, since I want to look at the distribution of scores, this is just literally score count over time by which exam it was. So then you can really see that they're phasing out everything but the math and English exam. Good to know. And I kind of got me in the mindset of thinking, well, what are all the other things that can go wrong? Let me actually give you guys a bigger view of this. What are all the things that could possibly go wrong? And so I got to thinking, if the average scores change, because I think, gosh, the GREs changed score format, the SITs changed score format, so the scale of the test can change. And I've got this predictive model that says, based on the scores, it's putting people in one bucket or another. And so I'm in trouble if they decide that they want to change the average, they want to change the maximum score or something silly like that. Something basic that they have every right to do, and that they probably wouldn't tell me about, because again, I'm a little too far away from where these decisions get made. And so I've just got to keep an eye out for this. And so I end up doing a couple things with that one, which is I have the average score for every one of those 5 exams, and I actually have I won't get into the details, but I have some logic in here that has to do with I have some logic in here that has something to do with I got this fear that they would introduce a new exam and not tell me. And so I have something in here where I'm just looking at the number of records in this time period. And so if a new exam pops up that has more than a couple records, which is probably a blip, it actually starts showing up. I've got that worked into the filter somewhere. It might be, I don't remember if it's on the front here. But also, since these can go up and down a lot just because of whether they have a lot of starts or not a lot of starts, did a couple other things. One is I took, let's take a look at the table calculation here. There we go. That's right. So I'm actually using a moving average, and so that really flattens these curves out, which is handy. Moving averages are good when you've got noisy data. And then I use the size. Probably, honestly, if I could name one thing I love about Tableau more than anything, it's just how easy it is to use size in your visualizations, because since we work with student data, and sometimes we've got tens of thousands of students to work with, and sometimes we have hundreds, and so it's just really important context when you're slicing and dicing. Being able to show the number of records as the size or the color or something is just so handy. So I've got these little bubbles here where there's actually a big start. And so you can see where the bubbles are, there's a lot less variation because there's just more data there, so it trends towards the mean. And so I end up with this testing dashboard. And so one other thing I want to point out is that I'm increasingly taking a checklist approach here. So what I'm saying here is just pretty basic. Just, hey, look for the strange patterns. And again, this is something that I was in the process of handing to the data analyst. And so I'm trying to make it really simple to know what to do here. We ended up changing how we implemented the model completely, and so we don't use these exams anymore. So that never got implemented. So I'm going to tell you about something that did get implemented. Let's go back to, so I hope that was interesting. Get back to the main story here. So similarly, with all the inputs, we've got an approach. We've got a set of dashboards where we update them every time. Let me go back to this process actually. We update them every time, and this is what it looks like. We get the files. We get the files from the school. We get the scored files, and then we've got this these Tableau dashboards that are linked to those files, both the input files and the output files. And so it's just a matter, if you've done this, you know how easy it is. You just refresh the data connection, and you get a new population of data here. And so here, what it would look like is a new bar pops up here, and a new set of scores by distribution pops up here. And what I'm looking for with this particular variable is it's a numeric variable. It takes on a whole bunch of potential scores. So what I've actually done is I've binned it. Number one, I've binned it by just a fixed amount, and so you can kind of see what the extreme values look like with the blue lines down here. The other thing I've done, because this is ultimately comes down to making sure that the model worked, is I've color-coded them at the most important threshold in the model. And so I can see a couple things here. One, obviously we're missing some values here, and so we usually were able to fix that. Here we weren't able to get the values we needed, so we just proceeded without them. But most of the time when we see this, it's a chance to go back to the source and replace the data. So you can kind of see what bad looks like here. This is good, this is bad. And the second thing is I'm able to keep track of, is there something, there's kind of a broader question of, is the distribution of the input data changing? And if so, do we need to change the model? So with this particular input, the good news is, you know, stuff's happening at the margins here, and every once in a while we've got this blip. But I can see based on the difference between what I've color-coded blue, which is all the people getting sorted in one direction, and what I've color-coded in pink, which is people getting sorted in another direction, I've got you know, a pretty steady ratio here. So nothing to worry about too much. So that's input scoring. I've only got 10 minutes left. So I'm going to move a little more quickly. So with output scoring, I've got this challenge of how do I, you know, going back to what these models are made out of, we've got all these interaction effects. Here we go. We've got all these interaction effects. And so it's not just a matter of, you know, all well and good to make sure that the math scores have a steady value, but I want to make sure that the scores of people reflect not just what their math score is, which, you know, whatever happens here may get canceled out by something that happens at the next stage in the decision tree that might even be negatively correlated with the first thing. And so I want to make sure that the interactions are captured. And so what I first started doing with that was, you know, I'm kind of grouping the scores here. This is the bubbles here, number of students in different subsets here. I'm looking at the scores, and I'm grouping them by the different factors that are in the model. And I'm trying a couple things here. One of them is I'm making some notes here. So I'm saying, hey, I should see higher I-score here in certain cases. And I'm also using reference lines. Reference lines are really handy. Here I'm using averages. And so what I want to see is that the average, I want to see the average line is higher over here than it is over here. And then within this bucket, I want to see the average line higher over here than over here. Now, if this graph is putting you to sleep, I don't blame you. It's kind of hard to, like, it's sort of tedious to read through it all. And so I try to make it a little try to punch it up a little bit by making it really clear the pattern that I want. So I played around a little bit with shapes here. And so I'm using up and down arrows to show what should be above other things. And again, with the reference lines, but I'm just getting hampered here by the fact that I've got too many things to look at. And again, I'm in a process where I'm trying to hand this off to somebody who isn't going to have the level of patience that I do to kind of comb through every element of the predictive model. And so I've got to come up with something simple. It's got to be something they can do in a matter of minutes. And so my second to last attempt at a dashboard here took a checklist approach of, okay, I should see this pattern here. I've got little notes. I know they're hard to read on the slide. I should see this pattern here of this is higher than that. I should see these guys are higher than these guys. I should see, you know, the green arrows are higher than the red arrows. But it was still a bit much. So I'm going to wave a magic wand here, and I'll come back to exactly how I got here in a second here. But what I ultimately came up with was something that that is a one glance chart. And so what I did is I took all of the inputs to the model and I grouped them at their specific inflection points. So the point at which the scores change the most based on what that input is. and then I grouped them, and I'll show you this in a minute, how I did this. I grouped them in a way that there was a really clear pattern here of dark green in the upper left, light green in the lower right, and there's this sort of increasing green color to the left and increasing dark green color to the top here. And the idea was, if you see that, that's good. If you see anything different, just call Eric, because at this point we need to dig into, is something wrong with the model, is something wrong with the data, is something wrong with the scoring process. And let me show you what that actually looked like, in case you're having any trouble visualizing this. So this is around the time that we first created this process, and so you can see, I'll just go back and forth between the first and second and third. So you can kind of see it shimmers a little bit, but it has a remarkable consistency in the shape and color pattern here. And so again, the idea here is that you don't actually have to know anything about the model. You just kind of know what normal looks like, and then tell me if you see anything strange here. Okay. Everybody who's seen this, including people who don't even work at InsideTrack, that maybe I was showing this as an example was when we talked about Tableau or something, or people who I've talked about this presentation with, and here's this after we fixed the problem. It's pretty obvious something's wrong right there. And I had no idea that this is what it would look like when things went wrong. I just knew that it would look like this when things went right. And so there's actually a lot of ways this can look wrong. But the good news is when we see something like this, the answer is go check the data. And actually, funny enough, the source data was fine. It actually was something wrong in the scoring code that we were able to fix very quickly. And so, you know, disaster averted, because it would have been honestly months until we'd known for sure that something was wrong with the model, and we would have had to dig into whether, is it because the model isn't the best possible predictive model? Is it because the scoring went wrong? And as soon as we looked and the scoring went wrong, we would have felt like idiots. And so anyway, that's how I use Tableau to keep track of this process. And to give you a quick sense of how you can do this, let me skip over. I added some pieces to it. Give you a quick view of what that looks like. So for some of the particularly important variable relationships, I don't know if I can fit this on the graph here. They have a certain relationship that just absolutely breaks down once something weird happens with the data, which it turned out to be something simple like some field names changed. Honestly, some field name changed and that broke the automation. So obviously we fixed the automation so that it's not as sensitive, but again, I'm glad I found this out using the method that I did. And to give a sense of what this looks like, I'll leave you with a couple sets of tips here. Yeah, I'm almost done. So one is, what I did with this particular process is identify the most important variables. Like I said, bin them at inflection points so that you have as few categories as possible. And then I'm showing the average score in each bin of the color on the green scale. And then I've just arranged them in descending order. And so give you a sense of what that looks like. I've already binned them. The binning looks pretty straightforward. It's things like if you've used Excel formulas, it's not much more complicated than that. And so I just kind of drag them in here, and I'm looking, whoops. So I want to get the I-score as the color. That looks good. So I'm just dragging them in here one after the other, and I'm thinking, okay, is this following the pattern that I'd like to see? There we go. A little more differentiation in that subset. So let's throw this in there. That doesn't look good. Okay, so maybe I can do this in a different order. And if this doesn't look too fancy, it's because this is literally what I did. I just kind of played around with it until it looked good. And so now that I know I can come up with that pattern, I've been able to replicate it a few times. So maybe doing it live isn't the best idea, but okay, so you can start to see what it looks like. Let me add a couple of things here. Yeah, so like I said, this isn't glamorous or brilliant. It's pretty straightforward, actually. Whoops. And so let me bring it back to where I've got just a couple of these, and I'll show you how kind of know if it's working. I want to bring this above, bring that below. That's right. So let's take this pattern through. Okay, you see how even though I didn't do this, I did this very poorly. This is my 1-minute version. You can see what it looks like when it breaks. Something went wrong. some variables aren't really being taken into account the way they need to. So to close this out, this is a very that's a very particular problem that I've solved, and if you have a totally different process, totally different model, what I did exactly might not work. So to generalize, what I would encourage you trying, and it does involve some creativity, so I'm sorry I don't have a copy and paste process you can exactly follow, but to generalize, I think the process to follow at home is, number one, define a threshold for complexity and time of review. So for me, I just knew that if it took more than 60 seconds, I was probably asking too much from somebody who's busy and has a lot of other processes to manage, but that I also couldn't go get involved myself and look at it for more than 60 seconds, even if we decided that was the process. And so that was my threshold, is I had to come up with something that took 60 seconds. Because the more you have time to look at, I mean, by all means, go look at all of it and check everything. But there's probably some threshold for you or somebody else. Second, I think you're going to need an expert in the model's logic. And so that's to do things like, in the case of the model I just showed you, knowing what the inflection points are. It's going to be a lot easier for somebody who is or has become an expert in the subject or in the model to figure out what the inflection points are, or what's a good, clever way, if there's lots and lots of data or lots of variables, to figure out what the inflection points are or what the most important variables are. And then really where I'm going with all this is draw normal. So get a lot of data as much as you can, show what the model looks like when it's functioning properly using whatever the best process is for scoring. It probably is using the same tool that you used to build the model. And then draw normal, and then using your large and varied data set that you're feeding through the model, you can ask questions like, gosh, if the bubbles are bigger or towards the top, that's good. So write that down so you give somebody, whoever's looking at this, including yourself, a checklist, and then get creative until you can reduce the number of items to meet the requirements. And then create an efficient process for updating the view. And I'll leave this here. You can take a look at this on the website later. If you're watching this at home right now, then you can just take a screenshot. This is some beginner tips, but one of the most important things is it's really easy to just update a Tableau workbook with a new update a Tableau workbook with a new source, as long as the field names are the same. And if they're not the same, then your Tableau workbook won't work, and neither will your automated process. So that's a good thing. So that's it.